Hello friends, welcome back to my channel The Data Engineering Experience, and today we will start with two new topics, Google Cloud Dataflow and Cloud Functions. So this is the second video of this Google Cloud Data Engineering interview series. If you have missed the previous one, please do check it out. I will leave a link in the comment section below. So let's start with our first topic for today, which is Google Cloud Dataflow. Google Cloud Dataflow and Apache Beam are the same open source technologies, with Google Cloud Dataflow being the managed version of this Apache Beam in Google Cloud Platform. I will be using these two terms interchangeably, so please keep that in mind. Then let's start with our first topic for today, which is Google Cloud Dataflow. Just like the previous section, I have divided these videos into like three parts. First, we'll go through the easy section, then the medium, and then the questions with maximum level difficulty. Then let's start with the first set of questions. What is Apache Beam? What are P collections? And what are P transforms in Apache Beam? So you can say that Apache Beam is an open source platform. It's a unified model for both batch and stream processing pipelines, and it allows you to build complex data and processing workflows that are like portable across all different types of execution engines known as runners. So what are P collections and P transforms in Apache Beam? So you can say that the P collection is mainly a data abstraction layer in Beam, which represents a distributed, immutable, and possibly a bounded or an unbounded data set. And what are P transforms? P transforms are the operation that you perform on this P collection. So they can be part do, group by, combine, flatten, and all these other types of transformations. So you can elaborate on this further. Then how does Beam handle windowing? So you can mention that Beam handles windowing by its windowing strategies like fixed windows, sliding windows, session windows, and global windows. Then what are the different runners that are available in Beam? You can mention the Google Dataflow runner, the Flink runner, the Spark runner, the Direct runner for your local execution, and finally the Samza runner. Then how does Beam handle data shuffling? Beam handles data shuffling by using the part do and the group by transforms. So what happens during this transforms? The data that is shuffled between the workers, and it ensures that the same data with the same key are sent to the same workers for processing. Then what are the role of side inputs and side outputs in Beam? So side inputs are a small additional data set that can be used in that same P transform in additional to the main P collection that you are using. So this is basically used when you need to filter on a particular data set based on a certain predefined condition or a lookup value. And what are side outputs? Side outputs is a specialized part-do transform when you need to output multiple P collections from a single input. And what are the use case for it? Suppose you want to use two different P collections, one for valid records and other for invalid records. So you can do that using the side outputs. Then what are combiners in Beam? You can mention that combiners are a specialized P transform used for aggregation, and you can mention the two types of combiners that are present: the predefined combiners, which includes the sum, mean, max, count, and the custom combiners, which you can do by extending the combine_fn class. Then you have a simple question, difference between a map and a flat map. So what does a map do? A map applies a function and returns a new collection where the source element and the destination elements are one-to-one mapped. And what is a flat map? So a flat maps applies a similar type of function, but the source elements and the destination elements may not be one-to-one map. So there might be one-to-many map or one-to-zero map. Then explain the various type of transformation in beams like part do, group by key, combine per key. So I'm sure you can explain these simple definitions. We'll move on to the next question. What are composite transforms? So composite transforms are similar P transforms that are composed of like multiple transforms together. And what are their use? They make your code reusable and modular. So they serve the same function as a function in object-oriented programming. Then the interviewer might ask you what are the various type of input output sources that you have used along with Google Cloud Dataflow. So you can mention your input sources like whether it's a PubSub, Cloud Spanner, Google Cloud Storage, and your output sources like the BigQuery, Cloud Bigtable, or any other, like it can be back to GCS. So you can mention all your input and output data sources. Then what is the difference between the event time and processing time in Beam? So event time is the time where the data event actually occurred at source. And what is the processing time? Processing time is the time when the data is processed by the pipeline itself. So the definition is, yeah, quite simple. Now we'll move on to questions with medium level difficulty. Our first question is, how does Beam's watermarking mechanism work in case of streaming pipelines? So you can say that the watermark in Beam is an estimate of the system's progress in processing the events. So there are two ways. Any timestamp that is before the watermark are considered on time, while the events which have like a timestamp after the watermark are considered late elements, and then the system can decide like whether to handle it using data handling strategies or like to drop it. You might get questions like what are the trade-offs between different windowing and triggering strategies that are there for streaming processing pipelines in Beam. So you can say that there are fixed windows which are simple and predictable but may not be able to handle irregular events with irregular frequencies. Then you have the sliding windows which can capture overlapping windows and which are useful for like smoother rolling aggregations, but they have increased level of complexity. Then you have the session windows which are used for capturing periods of user activity but are harder to predict and configure. And then what are triggers? Triggers control when the results are emitted. So you can have the early triggers which can provide like a fast feedback but the results might be incomplete, and finally you have the late triggers which can handle late data but they increase the overall system complexity. Then you might get questions from like how does Beam handle large data sets and sharding in processing. So you can mention that for large data set, Beam automatically shards the large data into smaller pieces and then distributing them across all its workers. Then you might get questions from like global windows. So what are global windows and when are they useful in Beam? So you can mention that a global window treats everything like all the data as a part of a one single window, which means there is no time-based grouping. Basically, the time dimension itself is missing. This is very helpful when you are computing results over a long period of time. Then you might get questions from do fun class like what is a splittable do function. So you can mention a splittable do function allows like long running operations to be split into it multiple smaller parts that can be processed in parallel or can be resumed if they are interrupted. Now we have a very important question. How do you handle back pressure in a Beam streaming pipeline? So you can mention what back pressure is. It is occurs when like the system is overwhelmed by too much data. So there are less resources and there is too much data to process. So how does Beam handle it? Beam handles this back pressure by delegating this task to its underlying runner, like whether it's a Spring runner, Flink runner or a Spark runner, which manages this data buffering and throttling, and it can also scale these resources based on the needs. We have another important question. What are merge accumulators in Beam? So you can say that Beam In Beam, merge accumulators are used as a part of the combiner pattern. So when a data needs to be either combined or aggregated, especially when it comes to distributed systems, the combiner first processes the data across multiple workers, producing like the partial results called the accumulators. Then these accumulators are merged to produce a final aggregated result. So there are two types of aggregation that are happening. First, you have the local sum that happens in each worker, and then there is a global sum where like the data from all these local workers are merged globally. Then you might get questions from like life cycle methods in Beam. So you can mention the various life cycle method in context to like the do function class, like the setup, the start bundle, the process element, the finish bundle, and the tear down options. Then you might get questions from type hints and data encoding. So what are type hints? Type hints in Beam are like a way to specify the expected type of data elements that are being processed by the pipeline. So when you add this type of type hints to a transform, it ensures like there is a type safety and you can catch the errors earlier in the pipeline. And not at the at the later stage or the final stages of the pipeline. And what are data encoding? So data encoding refers like how the data is serialized and deserialized when there is a transfer of data between different components of a pipeline. And how does Beam ensure this data encoding? It ensures it by using the coders. Okay, now let's start with questions with difficulty level hard. So the first question is, what are accumulation modes in Beam? So you can mention the two accumulation modes, the discarding one and the accumulating mode, and you can explain them in like one or two lines. Then what are like states and timers in Beam? So you can say that the states allow you to store information about each element or key during the stream processing. And what are timers? Timers basically allow you to specific times to trigger an action like handling of late data or emitting results at any future point in time. Then what is serialization and deserialization in Beam? So serialization is like a process of converting objects into a format that can be sent across a network or saved to a disk. So like it's basically turning objects into its bytes. And what is deserialization? So it's just the opposite of serialization. It's converting the formatted data back to its object so that it can be used during processing. And where is the serialization and deserialization used? So it's used in all distributed systems where the data needs to be transferred across like different machines or worker nodes. So you might also get a question like, how do you share a variable across all the worker nodes in Beam? So the answer should be side inputs. So side inputs allow you to share data across all worker like configuration data, lookup tables, or any shared values that are constant throughout your pipeline. Then you might get questions like, how do you perform error handling in Beam? So you can say that we can do error handling in Beam like a normal Pythonic way, like using the try-catch blocks, or you can use the side outputs that we previously discussed. Then you might get a tricky questions like, what are features that are available in Java SDK that are not there in Python SDK? So you can mention like for stream processing there are states and timers which are not available, like not properly available in Python SDK. Then you have this splittable do function which are used for large scale handling. Right now we have limited support, but full functionality is not available. Then there are some advanced IO connectors also which are not available in Python SDK, but they are available in the standard Java SDK. Then you might get another tricky questions like, how does Beam implemented distributed checkpointing for exactly one semantics in streaming pipelines? So you can say that Beam relies on the runner to handle is checkpointing. So if you are using Google Cloud, then you will be using the Google Cloud Dataflow runner to like process the data only once. So this checkpointing saves the progress of the data processing at like every specific interval. So if a failure happens, the pipeline will be resumed from its last checkpoint. Then another very common question is like, how does Beam achieve cross-platform portability? So how does it achieve? It achieves through what we call runners that we previously discussed. So the distributed system like Dataflow, Flink, Spark. So these are the runners that what you say handle the cross-platform portability. So you can like write the pipeline only once in your preferred language, like whether it's Java or Python. You can use any SDK of your choice, and then the Beam translates this logic to a compatible whichever like runner you plan to choose. So let's start with our next topic, which is Google Cloud Functions. Let's start with the easy section. The first question is, how do you trigger a Google Cloud function? So there are various ways to trigger a cloud function. You can do it either via HTTP request, via PubSub messages, via Google Cloud Storage events which are connected to Event Arc, or you can trigger it from other Google Cloud services like Firestore, Analytics, or any other custom services which are integrated with the Event Arc. Then what is the maximum execution time for a cloud function? So for Gen 1 cloud functions, the maximum execution time limit is like 9 minutes, and for the Gen 2, which is the newer one, for HTTPS cloud functions, it supports up to 60 minutes. Then what are the languages that are supported by cloud functions? So you can say that Python, Go, Java, .NET, Ruby, Node.js. So these are the languages that are supported by cloud function. Then you can get questions like, what is the difference between cloud function and cloud run? So you can say that cloud function is designed for like small event tasks where like it needs to automatically scale in response to events. But when it comes to cloud run, it's specifically for like containerized application, and it's more suited where you need to deploy web applications or APIs or any other long running processes where you need some level of control over the environment. The next question is, what is the purpose of environment variables in cloud functions? So you can say that environment variables allows you to configure your data secrets or any other settings that is basically outside your code. So this can include your API keys, your database credentials, or any other settings that can change between environments, like from development to testing or production. So this environment variables ensures that the sensitive data is not encoded directly into your cloud function source code itself. And how does it help us? So it makes your code much more secure and easier to manage. The next and the final question is, what are the advantages of Cloud Function Gen 2 over its Gen 1 counterpart? So you can say that Gen 2 has longer execution time, like 60 minutes versus 9 minutes for Gen 1. Then it's highly scalable, it has more resource option, it can respond to more event sources, and also it has greater regional availability. So let's finally start with questions with medium and max level difficulty. Our first question is, how do you implement error handling in Google Cloud Functions in context to data processing pipelines? So the easiest way is to use the try catch block. So you can use that normal Pythonic way of using a try catch block and ensure all your failures are properly handled. For automatic retries triggered via PubSub or HTTP, make sure that the number of automatic retries are set to a lower value. Also ensure that your logs are uploaded to Google Cloud Logging for monitoring and alerting purposes. Now we have a very important question. How do you ensure idempotency in Google Cloud Functions, particularly while handling data ingestion events? So you can do it by multiple ways. First, you can use a deduplication strategy like assigning a unique ID to each event. Next, you can do it by querying a cache or a database and checking whether the event has already been processed previously. You can also store the event state in a persistent storage system and skip the current processing if the event has already been handled previously. Next question we have is, how do you handle schema evolution in a BigQuery table using Google Cloud Functions for real-time data ingestion? So for that, you should use BigQuery client library to dynamically modify the table schema in response to the new fields or the new records that you are getting by adding the new columns to the destination table as and when required. You can also implement a schema validation process in our cloud function that checks like the new data against the current schema that is there, and you can update the source schema or the destination schema accordingly. So the next question we have is, how do you implement data deduplication in cloud functions while ingesting large volume of streaming data into BigQuery? So you can do it via two ways. You can implement BigQuery's merge statement to perform deduplication while inserting the records, or while using pub/sub, you can add the timestamps to the record that ensures that only the unique records are written into the destination table. Then our next question is, explain how you can handle back pressure and throttling in a Google Cloud function while consuming high frequency events from pub/sub. So you can do it via various ways. You can control the concurrency by setting the max instances in the cloud function. You can batch your messages together to process multiple events per function invocation. Then you can use DLT or dead letter queue topics for failed messages. Then you can implement retry policies that have an exponential backoff. You can also increase your acknowledgement deadlines to give more times for your message to get processed. You can also set up monitoring and alerting for your function performance. Our final question is a bit tricky. So it's asking us to describe an approach to manage a state across multiple cloud functions in a real-time data pipeline. This question is a bit tricky because cloud functions are inherently stateless by nature, so managing the state is a bit difficult but not impossible. So how do we do it? The solution is to choose a state management solution first, like either Google Cloud Storage or Cloud Firestore or Cloud Memory Store, or we can use Cloud SQL. Then we can use pub/sub to communicate between the different cloud functions. Like the first cloud function will publish the message to the topic, and the second cloud function will subscribe to the topic and pull the messages. We should also implement state versioning in case of an update to the state using the standard versioning techniques like either timestamps or incremental counters. This will basically ensure that we are always operating on the correct version of the function state. We can also decide to use Google Cloud Workflows if we are using multiple cloud functions together while maintaining the state between the steps in the workflow variables itself. At last, we have reached the end of this long video. So if you liked the content, please subscribe to my channel and share it with your colleagues or friends who might find this videos helpful. Also, please do not forget to press the like button, as it really motivates me to make this kind of videos. If you have any feedback, please leave your opinion in the comment section and I will try to address them as soon as possible. Thank you and see you in the next video. Goodbye.